Okay, now that we have these two 35-degree cuts done on the scope rings, the next logical choice would be, you would think would be to machine the corresponding 35-degree angle cuts on the top. But I'm not going to do that, and I'll tell you why. If you look at the drawing, you see there's a big notch to be taken out of this the lower base ring. And if I go ahead and take these cuts on this top piece, it's going to reduce the amount of area I have to clamp on the sides. And then taking this big notch cut out of here, the part might move on me. So rather than do the second set of angle cuts, I'm going to do this notch now. Okay, then we'll go later, after that's done, I'll go back and do the 35-degree cuts on the top. So to do that, we have to make a cut here 0.677 inches deep to the center of an 1/8 inch radius, and then we need to angle down 5 degrees. So it's going to be a two-step process. I'm going to use an end mill with a 1/8 radius on the corner. I'll go in and I'll mill this first surface, this 0.677 inch surface in, and then we'll angle the part 5 degrees and then take another cut to create that surface. So let's go ahead and get set up to do that. Just put the part in here like so. Use the second part as a spacer in the vise jaw to keep the vise jaw from rotating. I know I keep telling you guys that, but it's really important. If you don't do that, the vise jaw will rotate. If you put the part at one end and clamp on it, the jaw will rotate, and when you go to take a cut on it, the part will move. You know, because it's not clamped evenly across the surface of the part. So always support the other end of the jaw if you're working from one end. Okay, so that 0.677 dimensions taken from this surface right here, the top of the lower ring, the base ring. So let's go ahead and pick that up. These are all finished surfaces now, so I don't want to mark them. So rather than run the cutter and just run over and touch it till it bumps and leave a mark, I'll just leave the cutter still, and we'll use a piece of paper as a feeler gauge to feel when the cutter is almost touching that surface. So I'm just going to slowly move the part toward the cutter till the paper pinches like that. This paper I know is 4/1000 of an inch thick. Okay, so once we touch it, I'll zero out the dial, or the DRO in this case. Move in another 4/1000. Zero it out again. Now I know the cutter is lined up with this top surface. Now I need to go 0.677 inches to the center of that 1/8 radius. So we have to go 0.677 plus 0.125. So you can use the trusty calculator to do that. 0.677 enter, 0.125 plus 0.802. According to my reverse Polish notation calculator. You guys with algebraic calculators can do it differently. So 0.802 inches. Let's do that. That's about right there. I'm going to zero out. That's where I want to end up. Okay. Now I'm going to come back and I'm going to run the end mill down to the surface of this upper ring right there. Set my stop so it's a little bit off. And again, I don't want to mark that surface, so I'm just going to use my piece of paper, slide it under the cutter, and bring the table up until we get a little bit of drag on the paper. Right there. Okay, a little bit of drag. Now I'll set my dial for, well, I'm going to set it for 4/1000 before zero. And when I crank the table up to zero, the cutter will be even with this surface. Let me zoom in a little bit so you can see what's going on a little better. So now, got the cutter set for depth. I'm going to drop down 0.100. Turn the cutter on, and we'll just start taking a cut on this lower base ring until we get to our zero setting. too much off. This is as you machine apart, it gets lighter and lighter and less strong, so it's it's not clamped as well on the vise as it would be if it were a solid block. So take light cuts. You don't want the part moving on you at this point. That can ruin your day. Alright, I'm within 10 thousandths now, both in X and Z, so I'm going to move over 10 on X. This is right to 0, then I'll bring the table up to 0 and Z, and this will be the finished cut. One, something like that. Okay, that's one cut. Now, like I said before, we have to take another cut on this surface with the part tilted at 5 degrees. So let's go ahead and do this other part first before we break our setup. It's always a good thing to do all the parts you have to do before you break setups. I know I've made that mistake in the past. Find out you're one part short when you're all done and have to do a whole setup all over again. Alright. Drop table down 10 thousandths again and do the same thing as we did before. Technically, I should probably have tapped this part down tight on the parallels, but this is not a functional dimension. It's just aesthetic, so I don't really care if it's a little bit, a thousandth or two off, out of position. Just the looks. If I wanted to get a real accurate surface, I would have tapped the part down. This vise is pretty good. It doesn't raise up very much when you clamp the part. Your results may vary. You have to know your own equipment. Within 10, so let's go ahead and take a finished cut. Okay, so we're all done with that. Take a minute here and knock the burrs off, and we'll make that 5-degree cut. Okay, so now we have the first cut for this notch made. Now we have to take another cut on this surface on a 5-degree angle. And what we're going to be doing now is we're going to be blending two surfaces to a radius, right? So what I like to do is take a Sharpie, mark up the surface I'm going to cut so you can see what you're doing, especially on the radius, because we want the two radii to match perfectly so it looks nice. And to get the 5-degree angle, we have to tilt the part this way 5 degrees, right? So to do that, I'm going to go back to my trusty sine bar. So we have to tilt the part 5 degrees. So break out the calculator here, or if you want to go to the Machinery's Handbook, there's a table in there for sine bars. You can find out how big of a stack of gauge blocks you need. So we want to do 5 degrees, so we need to take the sine of 5 degrees Okay, and then multiply it by the size of the sign bar. In this case it's 2.5 inches from center to center. So we need a stack of gauge blocks 2179 inches. Okay, I'm going to use a 218. Close enough. Remember I said it's just for looks. 1/10 of a thousandth's not going to make much of a difference on a 5-degree angle. Okay, so I already made up my stack of gauge blocks. I said before I'm not gonna do that again because I already have a video out on that. So I'll build up the stack of gauge blocks, set the sign bar on it. Like I said before, I like to use a little rare earth magnet to locate the sign bar, so we get it in the same place each time. It doesn't move around. So that's good. There's our 5 degrees. Now we can set the part on the sign bar, push it against the stop, and again get our second part in the jaws at the far end. Make sure everything's squared up and lined up and snug it down. Alright, now there's no measurement involved here. All we do is just start whittling away at that blued surface until the radii blend together. So let's get it somewhere close, set the Z-stop, and just start taking cuts on it a little bit at a time, moving it in the X and the Z directions. We'll start out with X. You see it's starting to cut into the bluing I put on that surface. When it gets down close to the start of the radius on the cutter, then I'll start going down in Z. This is just by eye, okay? It's called blending a radius. Alright, now I'm down into the start of the radius, and I'll start bringing the table up. Watching the blued surface on the radii until it starts touching that. I'm just coming up a couple thousandths at a time, just kind of sneaking up on it. I think I don't feel any step there, so we're still good. Just keep coming up. Now we're starting to get into the radii a little bit. And there we are. Here's a nicely blended radius, okay? Two surfaces tangent to a common radius. So now we're all set. All we have to do is pop the other part in. Won't have to sneak up on that. We can just take it in one cut. Be careful not to move the sign bar. Get all the chips out. Okay, I'm gonna zero my X and move away a little bit so I can climb mill for the finished cut. Okay, so we're back to zero. There we go. Okay, so that finishes that. Kind of looks like the print now. So now all that's left to do is take these two 35-degree cuts on top. Again, we'll break out the sign bar, set it back for 35 degrees, and take those. Okay, we're down to the last operation. All that's left to do is take the two 35-degree cuts on this upper clamp ring. And looking at the drawing, that 35-degree angle goes down to 260 thousandths up from the parting surface. So what I've done somewhere is blued the one edge and scribed a line 260 thousandths down from the parting surface, and I'm just gonna mill to the line. Okay, this is just Sharpie. You don't need fancy layout die to do this sort of thing. Sharpies work great and they're a lot more convenient, so that's what I use. So I've got my sign bar set up for 35 degrees. I've got my little magnet down there to hold it in place. This one, unfortunately, we're going to have to use a parallel as a spacer because the part's narrower than the sign bar, so it gets a little awkward. But and also since we're putting a parallel in here, I can't use the other part as a spacer anymore, so I made up a stack of space blocks. These are just round gauge blocks, low tolerance, just for machining type stuff. So I made up a stack of gauge blocks, the appropriate thickness to support the other end of the vice jaws. So we'll just lay that in there. I got our part in place. Slide a parallel in to make up the difference. And snug it down. Okay, this is probably the weakest. Let me make sure there's no burrs on this thing. Yep, burr free. This is probably the weakest setup I've done so far, so I'm going to be really careful taking these cuts. Nothing worse than scrapping out a part on the last cut. Okay, so I'm just using a 1/2-inch end mill and a side mill. This cut. Don't need to set any angle or any dimensions or anything, because all we're going to do is mill to the line. It's already on the right angle, the correct angle. My end mill's going to be long enough, it's going to be close. I don't know if you can see that. Let me move the camera in a little closer. You can see I'm just milling to the line. Looks like we got about 30 thousandths to go yet. And now I'm splitting the line. I'll take one more cut. Fine mill cut, of course, to make a nice smooth finish. Alright, so that one's done. Okay, looks pretty nice. If this needed to be a really precisely located angle, I would lay it on a surface plate like this, and I would put a roll under here, a pin of known diameter, and I would measure over the part and the pin using trig to figure out what that measurement needed to be to precisely locate this angled surface. In this case, like I said before, it's just aesthetic, it's just for looks, so milling to a line like I just did is perfectly acceptable. Okay, so now let's flip it over and do it on the other side. After I take some burrs off, I don't want it setting crooked. Okay, get that surface deburred. Now we don't have much of a surface to work off of anymore. I'm going to have to be really careful when I set it up. The part doesn't tip. And I'll also zero out my x-axis so I know how far to go. We'll just duplicate our efforts here. I hear a little bit of chatter going now because this isn't a real solid setup. Hopefully that'll go away in the final cut. I'm only taking about 10 or 15 thousandths at a time, so I don't overload the part and move it. Alright, now we got 5 thousandths left, so I'll make a nice finished cut. Hopefully not chatter. It did chatter just a hair, so I'll take one more spring pass on it. And that should do it. Okay, there is all the machining's done on our scope ring. I'll go ahead and do the other side, and after that I'm going to go through. I have a nice fine needle file here. I'm going to go through and just break the corners. I don't want sharp edges on this thing, but I don't want big radii either. I'm going to do a nice neat job of just softening these corners a little bit. Okay, not going to go overboard. And when I'm done with that, I will hit it with a Scotch-Brite pad, get rid of all the machining marks, and then I have a few other parts I've been saving up. I'll fire up the anodizing bench and throw a coat of black anodize on it, and it should look pretty nice. I think before I do that, though, I think I'll throw it back on the gun so you can see what the finished product looks like. Okay, looks like we have a finished set of scope rings here. Looks like they look pretty nice. As good as anything you can buy, I think. They fit well. Everything clears. I think they turned out pretty well. So it's just some of the things you can do with your machining experience. It's kind of rewarding to be able to make something like this. You know, I probably saved myself a whole 50 or 60 bucks, but that's not the point. The point is these weren't available, so I had to make them myself. So I hope you enjoyed the series. Well, one thing I wanted to mention was all the techniques I showed you to make these things. That's just the way I happen to do it at this time. There are numerous other ways you could accomplish the same thing, depending on what type of machines and tools you have available. So that's the nice thing about machining. It's very flexible. You can just adapt it to whatever your needs are. So that's it. That's all I have for now. See you next time.